Okay, so let's go talk about Java expressions. Okay, boom. Okay. Okay. Yeah, I have a lot of stuff in here. Okay, let's talk about these functions. I've talked with you several times in the boot camp and sort of expressed strongly sort of my feelings that that a lot of things should be wrapped up in functions. We try to avoid writing large amounts of code at once. We try to build up things that are small and which are reusable, so the code can be easily introduced. It turns out that models, like programs in general, can be really hard to understand if they have a lot of code. Really hard to understand. And a model of modest size can get quite complex to figure out if you're not careful. And as a result, you can end up lacking confidence that the model is working properly. You can get frustrated with it, and stakeholders can become concerned. So it's very important that we keep models manageable. And this is one of the biggest draws of AnyLogic, is the fact that many of the other agent-based modeling systems require you to write large amounts of code. And they can turn into giant hairballs where no one really understands exactly what the model's doing. And that's disastrous. It's disastrous for scientific insight. It's disastrous for reproducibility. It's disastrous for communicating the model. And one of the best ways to avoid this situation will be to create a model which has lots of. Okay, I should really close this and open its AnyLogic 7 version. Have a model where the functionality is broken up into lots of small functions. Okay, lots of little things, each of which does undertakes a specialized function. Now, I thought I had an AnyLogic 7 version of this, but looks like maybe I haven't given it to you. I'm going to look at, okay, just going to look at these, if several of these might be suitable. But I think I will look at this one, a model with birth death. I'll try to provide this to you separately. Here we have a model where we have people divided up into distinguished in a number of different ways, including we keep track of family structure, the children associated with the mother. This is a demonstration model. And we have continuous aging, etc. And we saw yesterday that when we have continuous aging, we like to have this thing called current age. You notice it's capitalized here, which is contrary to my normal convention these days. But current age, for example, returns a very simple expression, but it's such that I can call it many places without having to repeat this expression. The danger is if we have some complex code, if we repeat it many places, we leave ourselves very open to a lot of dangers. One danger is people won't understand our model. A second danger is we'll need to go to fix it, and we'll fix it some of the places but not others. Another danger is that it looks cluttered and there's lots going on, and it will impede our ability to modify the model. Another thing is that it will be we can't easily have one person create part of a model, another person create another part so easily if they're all tangled together. So here, in this model, we have a variety of functions that perform various tasks. An example would be perform birth here. Now, the perform birth function, which is called associated with childbirth, when going from a pregnant to a non-pregnant state, undertakes several tasks. So you'll notice the basic operation tries to use functions and naming to name things. So you notice here it's saying person mother equals this. What does that mean? Can any one of you tell me? If you say person mother equals this, what does that mean? Okay, it's actually not creating an object. It's actually not creating an instance either. What it's doing is it's creating a name for a reference to myself. It's giving another name to myself. It's saying that you could call myself the mother, okay? It's actually not, and this is an important point, this is me, and it's actually just giving another way to refer to myself. But it's giving a name that in this context will be more helpful. I can refer to myself as the mother, okay? So, you know, if you go into a hospital, you know, sometimes people will say, you know, Mr. Osgood, and sometimes they'll say, you know, are you a visitor or are you a patient? I'd say, well, I'm a patient. I'm the patient. That's another name for it. I'm the patient. And that sometimes that's more convenient. So here, for this little bit of code, we're actually referring to the person who's giving birth as the mother, okay? Which I think is more clear. If you say this, people, you know, what am I in? Is this the baby or is it the mother? You want to be able to refer to myself as the mother, okay? And here and actually I'm violating my own thing. Occasionally I'll lapse into this. This should really be mother dot is infected, but we use it here. Okay, this is the mother. The baby's mother is the mother. The baby's infected if the mother's infected. And this should really say mother.ethnicity. The baby gets the mother's ethnicity. The baby has been born. The baby's ID is offspring, while the mother is such and such mother. And then we say establish the connections between the offspring and the mother. That connects up. Notice this is a function call. This is a call to a function. It should really be lowercase. But basically it goes through and for every connection the mother has, it establishes the baby's connection to that same person. So it gives the baby the same social network as the mother. And then it establishes the location of the baby based on the mother's location. Okay? And so we pass in the mother and the offspring as arguments, and it does its work. So here, you know, we have offspring being the name of the baby, mother being our own name, and it's just more convenient rather than saying this, it makes it clear who this is. It's mother. But secondly, you'll notice that I delegate here. The function here, perform birth, is broken up itself conceptually into pieces. The baby is born, but then we establish the connections of the infant, and then we position the baby to be close to the mother. But the details of that, we don't have to look at unless we want to. We just say, go do this. Go connect up the baby to the mom, okay? And we request that. Now, if we want to look at that, if we actually want to, then we have the option to do so. So we can go, and that's in a separate function. That's in a function here. Establish baby's connections based on mothers. Hey, come on. Here we go. Establish baby's connections based on the mother. Here we see, okay, if the mother has no connections, then we can just go on to connect the baby to the mother. If the baby does have some connections, if the mother has some connections, we go through each of those connections, we add it to the baby. Now, all this code, I could have put in perform birth too. I could have taken all that code we just saw, and I could have substituted it in here, right where we call perform birth, or right where this is called. But instead, I hide that code. I hide it because I don't want to have to look at things that are complex unless I have to. I don't want to have to reason about what that code does. Giving it a nice name, establish offspring's connections based on mother connections, is pretty clear. That's what it does. As far as how it does it, I only want to look at that if I have to. So one of the big virtues of making things in a function is you can give it a nice name. You could say is water, or you can say, is out of bounds. Instead of putting a long expression, you don't know what it does, saying if x is less than 0, or x is greater than 500, or y is greater than 0, or less than 0, or greater than 500. Rather than having a complex expression, you should be able to simply say is out of bounds, the x and the y coordinate, and have it return. This is much clearer. And then simply establish offspring's location based on mother's location. That's also something I could determine. I could put in directly into the code, but here it involves some calculations, and I don't want to have to look at that. I have enough complex things in my life. I don't want to have to look at code that's complex unless I have to. And it's much better to look at a nice name and you say, okay, I know what that does, fine. I don't need to go there, rather than having to reason through what this code does. If you just substituted this code in where it's being used, if you substituted this code in where it's being used here, you would just make it more complex for someone to know what's going on. So instead, you just call it, you have a nice name, and you call it, and if someone wants to look at it, they can. There's very little overhead for calling this. It really doesn't slow it down in any material way. And more than that, if you do that thing many times in the model, for example, for immigration or for whatever, you could call that same thing. You don't have to, you can use it many places, and you call it one place. If something goes wrong, you can fix it in one place. You don't have to go lots of places. You just go fix the definition of that method. So defining methods is one of the key techniques we use in AnyLogic and in programming in general to simplify our model. And a good model will use many such methods. So I think I gave you, for example, a model called the GDM model, gestational diabetes. This is a model created by a very talented software engineer in our group, and this has a lot of interesting features in it. But you'll notice the many methods that he defines as part of it. So he'll define, get BMI, get ethnicity, get fertility rate, get the age in years, get the sex, get birth, whether they have diabetes, have GDM. Note this, has diabetes. Now, you might think, well, why don't we just test what the value of the state chart is? But this is the point. If you just test directly the value of the state chart, now all these other places in the model where you're checking if the person has diabetes by looking at the state chart are dependent on the vagary of the state chart, whether you happen to have represented it one way or the other. And in this case, actually determining if they have diabetes. Now, where are my state charts? Here they are. Involves several tests. For example, do they have type 1 diabetes, type 2 diabetes, or gestational diabetes? So if you want to say, do they have diabetes, it is something which involves any of these conditions. Maybe in the future, we're going to split some of these so that gestational diabetes is divided into early stage and late stage gestational, or serious and mild. If we directly go and ask, are we in this state, say from a statistic, then when we change the state chart, that statistic may break. It may suddenly have to change because we're asking, is state active such and such, and it'll say, oh, I don't know what that state is anymore because we've changed the model, and we'd have to go fix that. If we just say in the statistic for the condition has diabetes, then we just go change has diabetes. When we change the state chart, we've changed one place, and the rest of the model will work. We've decoupled the rest of the model from the representation used. We've decoupled it from the details of how things happen to be represented in the model. So, in a way, it's like like a computer A good computer is. You request it to do something, and it will take care of all the internal details without burdening you with all of them. So it is a person, for example, here. You should be able to ask, do they have diabetes, without worrying about all the details of how they happen to have represented diabetes. So, this particular student, as a software engineer, put in place all these many functions, and it's those things that are used externally to this person. So outside of it, in the balance of the model, if you want to find out if a person has diabetes, you don't directly refer to their diabetes state chart. You just ask, has diabetes, and it returns true or false. Similarly, for getting the age, it hides the details of whether the person, how age is represented. In this case, it's represented dynamically, but he could represent it in any number of different ways, such as with a state chart, and it wouldn't change that. Get BMI, instead of computing it elsewhere based on the height in kilogram and the weight in kilogram, height in centimeters, he has it defined one place, and then you ask, what's the person's BMI as a function? You say, tell me your BMI. And it says, my BMI is such and such. And this is where it's defined in one place. So defining functions, specifying these things you drag in from AnyLogic, and then you can specify any information they need to take and whether they were just undertake an action or return a value. This is one of the most important steps you can take to make a model manageable in the long run and able to be nimbly changed in one place without causing all sorts of trouble in other places, because you just have to change it at the place the function is defined, and the rest of the model should just continue on and work well by calling that function. So anyway, we're going to go on and talk a little bit more about functions tomorrow, and we're going to be talking about this whole issue about why a person is an agent and how you can define males and females who share the characteristics of persons, but each have distinctive characteristics themselves, in a way that allows you to sort of you only define the common characteristics in a single place, and the ones that vary, those are the ones you can specify specially in the specialized cases, male versus female, for example. Okay? Any questions?
Could you ask in that explanation that you are going to give us tomorrow the use of implementation?
Of implementation? Sure. So there's implementations of several meanings in computer science. Could you help me?
When you have these problems with inheritance.
Yes.
And you have to call another. You are inheriting for two.
Oh, sure. Yeah, you're talking about interfaces and saying interfaces. Yeah, I'll talk about that. Yeah. Okay. Good. Okay. Thank you. It's 5:00. And look forward to seeing you tomorrow when we'll finish this up. Oh, by the way, another good aspect of modeling practice I didn't note, but just is visible right here. You'll notice that he's defined things that are constants here with this special symbol. If you have items in your model that are constants, that are reused in many places, for example, something in kilograms or grams or other values, you could specify as a constant in your model, and it will know to treat it specially and show it as a special indication with those double vars.
It never changes.
Yeah, it never changes. So you don't have to. It doesn't have to worry. Oh, it could change out from under you, and you know visually. Oh, that's something which is fixed. Okay. Okay. Thanks.